Hey guys, it's your friend Avi. I thought I would show you a little bit of different content today. A project I've been working on, an electronics project I've been working on for quite a little while now. Um, so this is actually a project to build a ultrasonic microphone. This is something that I have done a couple versions of, a couple prototypes of, using prototype boards, but I decided that I wanted to take this up to the next level and actually design my own printed circuit board or PCB for it and get those made and put together so it looks actually kind of professional. Um, and this I did pretty much all the design in a program called KiCad. And what this basically allows you to do is you have to start off by copying schematics. You have to create your schematics for it with your different components. So, we've got capacitors, resistors, transistor. These triangle things, these are amplifiers. Interesting thing to note is that this is actually pretty cool, is that like these three, there's actually four, we don't use all of them, but these three and also this here are all in the same integrated circuit chip. But you can basically, you're allowed to KiCad is really cool. It lets you do that. So that there's like four amplifiers on one chip. You can put them here on the schematics. And the reason I say that is that, like, for all of these things, all of these things have to have a footprint, which tells the circuit board, the PCB editor, like the shape and the outline and also the silkscreen, because there's going to be stuff painted on the circuit board that show like where stuff are supposed to go. And it's pretty cool that we've got like all these three things are tied to like the same symbol. So let me show you actually like the circuit board itself that I ordered. I've actually upgraded and modified my design since I've ordered, but for right now, this is what I'm going to be receiving from PCBWay. Is going to reflect what you see here. Very brief description here, explanation is that all the red things, these are the wire connections, are called traces, and the blue ones are also, the difference is that the red are on the top surface of the PCB and the blue are on the bottom surface. So it's one of the nice things that PCBWay from these companies, you can have even additional layers of connectors in between the board, in the middle of it. So like, I am not advanced enough to really be able to design at that level, to be honest. But it's just really super cool what you can do now and what you can get ordered and manufactured for yourself. The way that this works is that there's a microphone, and the microphone is going to be mounted on a little chip like this. This blocky looking thing is going to literally be like a block terminal connector. It's one of these like kind of blue or green chunky plastic things where it's got like little screws. You put like a wire into like a hole inside of it and you screw it down to tighten it, and it just basically connects onto the wire there. And this is going to be what actually holds onto the microphone element itself. The two legs, the positive and the ground for the microphone, are, I don't know, like 10 or 11 millimeters apart, and they will fit fairly well into here. I prefer this method versus direct soldering because these microphones, these ultrasonic microphones, are very heat sensitive. If you heat up the leg, soldering it too long, then you kill it and you've just lost like $25 like in an instant. But basically the way this works is that the microphone is basically tuned to its preferred frequency by connecting with a resistor and an inductor coil. And the microphone itself has kind of a tunable capacitance, and the combination of all this will kind of like help it stay around 25 kilohertz, which is well above the human hearing range. And then what ends up happening, that passes through here, it comes in through a jack. Like signal goes through a capacitor to this transistor. The ground from it goes kind of through the transistor also and into other parts of the circuitry. But basically this is the first kind of like signal amplifying thing right here is this transistor, and it passes it into a series of 3 different low noise amplifiers in this LM074 circuit, integrated circuit. And ultimately the signal will get passed through a final like more sound oriented amplifier LM386 before it goes either to a headphone jack, or if its headphone jack is unplugged, it will go to an internal speaker. It's got 2 variable resistors. One here, this actually helps to tune the frequency that we're listening to, kind of around the 25 kilohertz range. It will help you, this one takes it up or down. It does the tuning there. This one here acts as both a switch and the volume control, so both of these are like rotating potentiometers, so they are going to be kind of like a dial or a knob that you turn on the device, and the headphones would be plugged in this way. Like the knob would be up here, and the headphones would plug in here. And then the connector for the speaker for if you don't have headphones in is right here. This other connector down here is for your battery, and this will take between 6 and 20 volts power input. So I think like a 9-volt battery is probably good enough. So, you know, you might question, why would you do this? Why make an ultrasonic microphone? Well, you know, there's a lot of things in the ultrasonic range that we can't hear. There's sound from electronic devices. There's sound from insects. There's sound from other animals, including mammals like mice. There's a hidden world around us in the sound that we never hear. You know, the same can be said for light. You know, human beings can see only like a certain like less than a fraction of % of the total electromagnetic spectrum, you know, and so a lot of people think that, you know, what you see is what you get in life, but, you know, there's so much around us that's invisible. There's so much around us that we can't hear. It's inaudible, but that doesn't make any of it any less real than it actually is. You know, we tend to think that the world around us is only what we can sense, but that is leaving out, I think, like 99.99% of the actual universe, if you think of life that way. So that's why I kind of wanted to do this project. I'm pretty chuffed right now because I've ordered these from KiCad. I'm going to have it manufactured. The PCBs are going to have a blue finish on them. But the main board is going to look like this on the top and bottom and top, and then this is going to be a separate chip that's going to be for the microphone mounting. And so, you know, I'm really looking forward to these getting in. When I look at this, they actually came in processed through customs today. So I'm going to expect these like probably Monday, I think. And then at that point, I'm going to put it together. You know, I will show you at that time. So I'm not doing too much editing. I want to be a little bit lazy here and just post this particular update as like a standalone. But I will show you also my prototype boards and the first board that I ordered, which I think that's on this one. I ordered a main board previously, but there was a little bit of an issue with it because I didn't really understand the PCB design software very well, and I didn't give me warnings that there were things that are unconnected. I was missing a connection here between pin 2 and pin 4 of the LM386, and I was missing a connection between this side of capacitor 5 and was it resistor 10, like right here on the back side. So, you know, with the prototype that I did get, I was able to fix that by just wiring physical wires between these 2 points. But in the updated one, which is even not my most recent, because I have made this a lot more compact, I've gotten everything kind of scrunched a bit closer together for my next order, because, you know, I ultimately want to make this into a handheld device that's going to have like a parabolic mirror on it. You can like listen to stuff from a distance. But yeah, I think you can see, here's what I said I was missing there. I think we're rotated 90 degrees from the other picture, but between pin 2 and pin 4 there. And then C5 is actually connected through, I had to use a via, which means I had to switch the wire from one side to another and then back again. But it's actually coming from this point over to here on the back side. It goes on that via to go across right here, because I have to get across this wire right here, and then it goes here to resistor 10. So those were the things I was missing off my last one, but I fixed. So I am gonna, you know, not continue on with this video. I think this is good enough. I just want to kind of give you guys sort of an idea of other stuff that I'm interested in. Yeah, if you find this interesting or entertaining, I hope you like it. You know, if you want more content like this, let me know. Subscribe if you want to. I don't bash people over this stuff, at least not yet. But thanks for joining me. I hope you enjoyed. I hope you learned a little bit of something. Peace out.